We've looked at spanning tree, link aggregation, and now we've looked at VLANs, but we're going to revisit some of those topics to see how they work with VLANs. So we're going to call this our advanced VLAN topic. Well, let's suppose we've got two switches here. And for each switch here, we've got two VLANs set up. Oops. So let's configure VLAN 20 here, and let's suppose I've got a computer off here, and I'm going to use an IP address. In fact, in my example, I'm going to use the 192.168.0 network for all machines, even though I have VLANs. And we're going to put another machine on the second switch here. And it'll be 192.168.0. So this machine will be .1 and this one will be .2. So one question is, if I have these two switches and I've set up VLANs on them, how would I do that? Well, just to prove that the VLANs are set up and working properly, I've got a machine here and it's going to be set up as 192.168.0.3. So let's first look at the setup in Packet Tracer. So I've set up Packet Tracer here with these two VLANs. I've got two identical switches. I've called this switch 1 and this switch 2. If I try to ping between machines here and here, they're on different VLANs, we're going to get a failure. Obviously, it's not going to work if I go between here because I have no actual connection between here. If we go back to look at the picture, what I've done is I've configured ports 1 to 4 for VLAN 10, 5 to 8 for VLAN 20 on both switches. So there's two switches here. Let's go and just say, well, we're just going to add a connection between the switch here, and let's just suppose we're going to use port 10 on both. Well, we'll wait for this to become active. So we can see it's active, and we may think, well, I should be able to now ping between my switches. But we'll find that will fail. And of course, that's because this line is not in the same VLAN. Well, I've used port 20, so if I look at, if I look at the CLI, and if I look at port 10, we'll find that port 10 is, of course, in VLAN 1. It's not in 10 or 20. So what I need to do here is I need to make sure, that I make a connection here. If we go back here, what we need to make sure of is that we're going to make a connection that's going to be in the same VLAN. So I need to make sure here I make some connection here. So let's do that and try see what happens here. So we're going to add a connection between the switches. It needs to be a crossover cable. This is VLAN 20, and VLAN 20 is 5 to 8, so I'll use 6, and I'll use 6 here. And I'll wait for that to become active. So now that we've got this connection, we would expect a ping between these two would work, which it does, because that's in the VLAN. And of course, between those VLANs, I'm going to get a failure. What if I want to connect up these two VLANs, VLAN 10? So if we look back at our diagram, how would we normally connect that up? Well, of course, we would make sure we have a connection here, and that should connect VLAN 10 and allow me to connect to my other machine here, which is .0.4. So let's try that. We're going to use a crossover cable, 2 on both of them, 2 on both switches is that VLAN, and we'll wait for these to become active. So now that they've become active, let's try our ping in VLAN 10. We'll see that's successful. A ping here is successful. And even though all these machines are in the same IP network, and we wouldn't normally set that up this way, this is just set up for illustration purposes to show that the VLANs are really separating the traffic. That is, the switches are separating the VLAN traffic. Each VLAN is a network, so normally each network should have its own unique IP address range. But if I go between here and here, I'll get a failure. Or between here and any other machine. So the VLANs are working. Now, one question which comes up is that, what about spanning tree? How does that implement? Because it may appear here like I have a redundant loop. I've got 2 connections between the switches. And one question is, why is spanning tree not shutting that down? Well, we're going to go back into our switch setup for one of the switches. And we're going to show the running configuration. And one of the things we're going to look at here is spanning tree mode, and it will say PVST. So, PVST, what's that? Let's take a look. So what this stands for is per VLAN spanning tree. And this is something that's relatively proprietary to Cisco. And what Cisco does is treat these as 2 separate switches. So if we just look at the top switch, we do not have any redundant links. We just have one link between the 2. This is treated as a separate spanning tree network, and you'll notice that there are no redundant connections. Now, this doesn't happen on Dell switches and some others. There is another standard, but for Cisco, it treats these as independent spanning trees. So, how can we tell that? Well, let's look at some spanning tree information on one of the switches. If we go show spanning tree, what we'll now see is we'll see VLAN 10, we'll see spanning tree information, interfaces that are in the forward or blocking mode, and we'll see a whole new set of configuration for VLAN 20. So let's see if we can, how we would set the VLAN or spanning tree information with VLANs. What I want to do here is, with spanning tree, I should be able to make one of the switches the root, but because of PVST, each VLAN is like its own little switch. So I'm going to show how to make switch 1 the root for VLAN 10, but switch 2 here the root for VLAN 20. So we'll go into, and what I've done is I've set the MAC addresses to the left of the switches so you can identify which switch is what. So if we go into our command line interface for switch 1, we would go to the config mode and we would say spanning tree VLAN 10 root primary. So that makes for VLAN 10, this switch, the root, and it should lower that priority from 32,000. Now let's go on to the switch 2, so you can see here. And we'll do the same thing, go into configuration mode, spanning tree VLAN 20, root primary, exit. And so it will take a little time for this to propagate through. But if we now look at showing the spanning tree information, we'll see the root ID priority is been lowered from 32,000, and this is the address of the root, and notice that's over here, which is switch 1. Even though we're on switch 2, it knows the root's over here for VLAN 10. But for VLAN 20, here, for VLAN 20, this bridges the root 007, and 007 is the switch 2. So what we've done there is we've set the root based on VLANs. Now this is not done in Dell switches or other switches, so it works different that way. So let's at least discuss that. So in other switches, spanning tree might only be done on VLAN 1. So let's look at if we did this with Dell switches. What would happen is we would have these two connections which aren't in VLAN 1, so spanning tree is actually not active. So spanning tree actually only works on VLAN 1, and it would be up to the admin to ensure there are no loops in any other VLANs. They're just not checked. So if we had, on a Dell switch, if we had a second connection here, the Dell switch, that would be a problem. You'd get broadcast storms on a Dell switch. But on a Cisco, where they have per VLAN spanning tree, it would shut down one of these redundant links in VLAN 10. So that's spanning tree and how that works with VLAN. Now let's look at a link aggregation example. Let's look at what happens when we do connect a second line in our VLAN 10 here. So we're going to take another crossover cable and we're going to connect it to our VLAN 10. Let's look at, it should be 3. And let's connect to 3 over here. And we'll just let that settle, the simulation settle out for a second. So now our simulation has settled out, and what you notice here is that spanning tree has shut down one of these ports here. So we have 2 connections on our VLAN 10 here, and spanning tree has shut that down. So let's suppose we want instead to have a link aggregated port. So we don't want to do this, and what we want to do is put this into a single link aggregated channel. So physically there's going to be 2 links, but logically it's just going to use the LACP protocol, and we want to have a port channel. So let's see how we would set that up in our system here. So what we have is we have lines 2 and 3, and we want to add a port channel. So one of the first things we have to do is set up a port channel. So we're going to say int port channel, and you could use whatever. We'll call it port channel 10 because it's going to go in VLAN 10. We may need to just number them from 1 to 2. Doesn't look like it took 10. So switch mode access. So we're going to make this port channel an access as opposed to a trunking. And we're going to make it a part of VLAN 10. And so this is important that we use that command. So now we've set up a port channel on this switch that's part of VLAN 10. And we'll need to duplicate that over here. Switch port mode access, switch port access VLAN 10. So now we've got both port channels set up, and now what we need to do is we need to add the interfaces to the port channel. So int FA0/2 is the first Ethernet interface. And we'll say channel group 1 mode access, so that, oops, that should have made that an active. And that came up and down. We need to do the same with the FA03 because we're using ports 2 and 3. Group 1 mode active. And so now on switch 1, we've set that up. We'll go here to switch 2. We'll add int FA0/2 port 2 channel group 1 mode active. Comes up and down as it configures it. Int FA0/3. We're going to add that to the channel group as well. And we'll give that some time to settle out. What you'll notice now is that ports 2 and 3 here are both green. We both get green here. We now have a link aggregated port. We should between here. Sometimes in the simulation it'll turn brown for a while. I'm not quite sure why that is. If these ports were truly down, I would not be able to get a ping across, so obviously that's not accurate. These are all green and those are set up properly. VLANs, it can have effects on spanning tree, and for Cisco switches they use PVST. Each VLAN has its own spanning tree network. That's not true in third-party switches like Dell. They only have spanning tree on VLAN 1. We've also shown how to connect two VLANs from different switches, so we need a connection to make sure a single wire that's in the VLAN. If we have multiple wires and we have a loop in a VLAN, spanning tree will shut it down. And finally, we showed how to set up link aggregation. We'll quickly show you some of the commands on the next slide that we've used. These are the commands we used. Spanning tree for VLAN 10. We want to set this switch as a root primary. Now, you can actually set the bridge ID here, but the VLAN 10 specifies we're talking about the spanning tree system in VLAN 10. To set up link aggregation, we need to set up a port channel. We start with number 1. we make it an access as opposed to a trunking. We'll learn about trunking later. And then we tell it what VLAN that port channel is going to be a part of. Here it's VLAN 10. To assign individual channels to a port channel, we make sure we go into the configuration mode of that interface, and we say channel group 1 mode active.